All right, welcome to the notes on Chapter 8, Section 5. We're going to add and subtract rational expressions. Um, Buckle up, because this is going to be difficult. And it's just difficult because it's technically difficult. It's not the concept, I don't think. It's the actual execution of the algebra. So first of all, finding least common multiples in expressions. So what is the least common multiple of this and this? So what we do is we find the prime factors from each expression. Um, we write the product of the prime factors, each raised to the greatest power that occurs in either expression, and that's what we get. So the least common multiple here for all of this is 36x squared y cubed, x plus 1y squared, x plus 4. Whew. Okay? Um, yeah, that ain't easy. All right? But again, this stuff over here is useful. You know, how do you determine the exponent of each factor for the least common multiple? Use the exponent from the expression that has the factor to the greatest power. So if we look at, 12x squared y, x squared plus 2x plus 1, if we look at each one of these things, we're trying to find least common multiple, so what they share, okay? Um, and it's again the prime factors are a big deal. It's a big deal. So 12 is 2 squared times 3. Then we have x squared y, and then x plus 1. This has to be factored to be x plus 1 squared. So we just get everything down as factor as much as we can. We do the same thing down here. This is 2 times 3 squared, and then x y cubed, x plus 1, x plus 4. And then we write the product of the prime factors, each raised to the greatest power that occurs. So that's 2 squared as the greatest power, 3 squared, x squared, y cubed. It's the greatest power. X plus 1 squared, x plus 4, and then we put that all back together. You've done these common multiples before, just never quite this messy looking. So go ahead, and here's a little bit of a cleaner one here. What's the least common multiple of these? 2x plus 4, and then x squared minus x minus 6, and then down here, what's the least common multiple for these 3? And you're going to have to factor each one of these to figure this out. Go ahead and pause the video, try and factor these and find the least common multiple. Go ahead and do that now. All right, you're back. Forgot it. 1a, the least common multiple is 2 times x plus 2 times x minus 3. For b, the least common multiple is x minus 1, x minus 2 squared, and x plus 4. All right. Finding the prime factors first, and then putting it back together with the greatest, the factor of the greatest power. Okay. We do that because we have to understand least common denominators. So recall how we used the least common denominator to add fractions. So you guys remember this. This is 1 over 8 plus 1 over 10. And then we make them so they have we change the way they look so they have the same denominator, and then we're able to add. Well, we have to do that same thing now with rational expressions. So what's the sum of these two? Well, if I factor this to this, I can see that it's missing an x minus 2. So I multiply top and bottom by x minus 2. I put it together. I factor again if I can, and then simplify again if I can. And so when we add this expression to this expression, we get this, and then we make sure we account for the restricted values. Okay, guys, this isn't easy. It's just not. So let's go ahead and let's try these A and B. We can walk through A together. That might make it a little bit easier, and then I'll let you try B on your own. So let's walk through A. If these video notes are a little bit longer because of it, then, well, so be it. But so we have x plus 1 over x minus 1 plus negative 2. And I'm going to factor this so that it's x times x minus 1. Well, what I notice is that the denominators to be the same, I need to multiply this denominator on the left by x. So that's what I'm going to do. I'm going to multiply this by x over x. All right. So now I have x times x plus 1 over x times x minus 1 plus negative 2 over x times x minus 1. Now that they're both the same, I can put them together. Okay, so this, and I'm going to go ahead and distribute all in the same step. So I have x squared plus x minus 2, that's the whole numerator, over x times x minus 1. Then I'm going to see if this can be factored. Okay, I'm going to see if I can factor it. And you know, sometimes you might not be able to. That's okay. Those problems exist. But this is x plus 2 over, times x minus 1, and then that's over x times x minus 1. What do you notice? You notice that those are the same, so they can divide out. So my answer is x plus 2 over x, and x cannot be equal to 0 or 1. Okay, so that's got it, number 2. What I need you guys to do is to try, sorry, if I went too fast there. So that's got it too. I need you guys to try 2b on your own. Go ahead and pause the video here, see if you can get 2b. All right, you're back from pausing. 2b is, whoops, 2b is 2 times x minus 1 over, now, if you have this factored out, if you have it as x plus 2, x minus 2, or x squared minus 4, either way is fine. And then x cannot be equal to plus or minus 2. Okay. Part C says, if you didn't get that, try again. If you did, awesome. If you still can't, make sure you ask about it in class. Part C says, is it possible to add the rational expressions in problem 2 by finding a common denominator, but not the least common denominator? So back to problem 2, is it possible to add these by finding a common denominator, but not the least common denominator? And the answer to that is yes. However, you'd have to factor again at some point, and the limitations on x would end up being incorrect. So the least common denominator is a big deal. Can you still simplify it? Yes, but you're not going to get the restrictions right, and you're going to end up creating more work for yourself. So that's the answer to that question right there. Problem 3, subtracting. So same idea. We have to get everything least common denominator. And then we have to make sure the big deal is in this step right here. When we put this together as one fraction, this needs to go in parentheses so that we correctly apply this negative sign, that we distribute it to each term. If we don't do that, we're going to get it wrong. So that is the big deal step. Everything other than that is the same for subtracting as it is adding. Pay no attention to this right now because that could scare you. So, since we just did one together and one on your own, let's try these two on your own. Same exact kind of thing, factor, find the least common denominator, put it together, make sure you distribute the negative sign to the numerator, make sure you account for restricted values, do all of that, get the answers for 3A and 3B. Do it now, go. All right, you're back. Hopefully for 3A, you get x minus 2 over x minus 1, and x cannot be equal to 1 or 2. Okay. And for B, hopefully you got x squared minus x minus 4 over x squared plus 5x, plus 6x plus 5, and x cannot be equal to negative 5 or negative 1. All right, so hopefully you got those. If you had these factored at the bottom factored here, that's fine. Hopefully you got those, and if not, try them again. If you still don't get them, make sure you do something so we can go over them in class, okay? Move these out of the way so we can see what's underneath this box down here. So underneath the box, we're going to talk about a phenomenon called complex. A complex fraction is a rational expression that has at least one fraction in its numerator or denominator or both. So these are fractions within fractions. So you'll notice that this numerator has two fractions in it and the denominator does. And here's a fraction divided by a fraction. And then here's adding two fractions and then subtracting two fractions. And yes, these are all real things. And they look complicated. So they look complicated, but you know, we just do it a little bit at a time, and we see what we can figure out. So sometimes what we're able to do is we're able to simplify a complex fraction simply by multiplying the numerator and the denominator by the least common denominator of all the irrational expressions. Then we can simplify them in the fractions one at a time, and then multiply the numerator by the reciprocal of the denominator. So what does that mean? All right, here's what it means. if we have 1 over x plus x over y over 1 over y plus 1, the least common denominator of all of this is xy. So we're going to multiply everything on here, each term, by xy. What we get is, we get 1 over y, or sorry, right here, we get y plus x squared over x plus xy. Okay, so that's all we have to do. It kind of cleans itself up. Another way to do it is you can combine the expressions in the numerator and those in the denominator, and then multiply the new numerator by the reciprocal of the denominator. So that's another way. So we could just find a least common denominator here and a least common denominator here. Once we get those, we end up with those down here, and then we have to know that 1/4 over 1/2 is the same as 1/4 divided by 1/2, which is the same as 1/4 times 2 over 1, which is 1/2. So that's what happens from here to here. Instead of writing it like this, they write it as a division problem, and then instead of dividing, they multiply by the reciprocal, and hopefully you're noticing that this answer and this answer are the exact same things, okay? This is a mess, all right? And the only way to really work at these is a little bit at a time, and these problems are going to take some room on your paper, and you know what? We're going to deal with that because it's big kid math time. So, go ahead, take a second. I'm not going to help you with these. I want you to give your best crack. 4A, 4B, as best you can. Ready, set, go. All right, you're back. All right. Hopefully you have something written down. If you have nothing written down, you're not going to learn anything from this, and you're going to have to hope in class that you're awake enough or alive enough or enough people ask so that we can go over this enough times. But hopefully you tried this and you did one of the methods. And for 4A, you got x squared y over x plus y. And then x cannot be equal to 0. It can't be equal to negative y. So x cannot be equal to 0. X cannot be equal to negative y. And y cannot be equal to 0. All right. Hopefully you got all that. For B, B was a mess. Hopefully for B, you have x minus 1 squared, let's get rid of that, over 2x. And the restrictions there are x cannot be equal to negative 2, negative 1, 0, or 1. If you didn't get those, I really suggest you try them again. Just sometimes trying it a second time, you can find your mistake. If you still don't, make sure we go over it in class. Using a rational expression to solve a problem. So here's all this big equation about a woman driving an SUV that gets 10 miles to the gallon. Her husband drives a hybrid. Every week they travel the same number of miles. They want to improve their combined miles per gallon. They have two options on how they can improve it. One is they can tune the SUV and increase its mileage by 1 and keep the hybrid as it is, or they can buy a new hybrid that gets 80 and keep the SUV as it is. So which option gives them a better miles per gallon? So we're going to compare them. We're going to do option 1, which is this, and option 2, which is this. And then we end up calculating all this stuff. We simplify our way down, and we end up getting the combined miles per gallon is this for one and this for the other, so option 1 is the better plan. Okay, this stuff, they make this stuff to seem so much more complicated than it actually is. Suppose there's a third option though, to buy a new hybrid that will get double the mileage of the present hybrid. The SUV mileage stays the same. Which of these three best options gives the best combined miles per gallon? All right, so now you're doing a new option, okay? You're doing a new option, so you're going to base your formula off of what they have, okay? Option 3 is buying a new one, a new hybrid that gets double the gas mileage of the old hybrid, okay? Double the mileage. So, see if you can come up with setup there and solution. All right, you're back from that. Hopefully you got that option 1 is still the best. That's this one. The new gas mileage, combined gas mileage, it was better than this though. It was 18.46 miles per gallon. So better than that, but not as good as option 1. All right, that's it for the notes, guys. Yeah, this stuff ain't easy. Please help me, help your classmates, make sure everybody's watching this. Text somebody and tell them they should watch the notes. All right, see you guys tomorrow.